Hey everyone, so every single time you go online, you're using this invisible system of addresses that makes the entire internet, well, work. But here's the thing, that system was built for a world that doesn't exist anymore, and it has pretty much run out of room. Today, we're going to dig into the massive, absolutely critical upgrade that's happening right now to keep our digital world from hitting a dead end. So let me ask you a question. What do your phone, your laptop, and yeah, even your smart fridge all have in common? Well, they all need a totally unique number to connect to the internet and actually talk to each other. I mean, without one, they're just really expensive paperweights. That number, it's the key to everything. And that unique number is called an IP, or Internet Protocol Address. The absolute simplest way to think about it is like a digital mailing address. You know, for a package to get to your house, it needs a specific street and number. Well, from an email or a video to get to your phone, it needs a specific IP address. It's basically the internet's universal postal service. But here's where our story gets a little tricky. The original system for these addresses had this huge and, let's be honest, pretty predictable flaw. We were always going to run out. Just imagine a brand new city that only planned for 1,000 phone numbers, and then 1 million people move in. Yeah, that's pretty much the crisis we've been facing. Okay, so the first system, which was created way back in 1981, is called IPv4. It uses what's known as a 32-bit number to create all these addresses. Back then, you have to remember, the internet was this tiny community of researchers and academics. A 32-bit system seems like an impossibly huge number of addresses. And that 32-bit system gives us our magic number, just under 4.3 billion unique addresses. In the early 80s, this felt almost infinite. I mean, the entire world's population was around 4.5 billion, so the idea that we'd ever need more than that for computers just sounded like science fiction. Nobody could have predicted we'd all be carrying multiple internet-connected devices right in our pockets. And here's the crazy part. It wasn't nearly enough. With the absolute explosion of smartphones, laptops, smart everything, that pool of 4.3 billion addresses officially ran dry way back in 2011. Just think about that for a second. For over a decade, we've been living on borrowed time. So, how is the internet still even working? Well, the answer is a very clever, but also a very clumsy workaround. The internet didn't just crash and burn. Instead, engineers came up with this really ingenious patch to keep everything running, while a much bigger and more permanent solution could be built. That patch is called Network Address Translation, or NAT for short. The best way to get your head around this is to think of your home Wi-Fi router as an office receptionist. See, in an office, you might have dozens of employees, and they each have their own private phone extension, right? But to the outside world, there's only one main phone number for the entire company. The receptionist, your router, takes all the incoming calls and makes sure to direct them to the right person. NAT basically lets all your gadgets share one single public IP address. But you know, this whole receptionist model has its flaws. It kind of breaks the internet's original promise of direct device-to-device communication. If you've ever gotten one of those super frustrating NAT-type strict errors while trying to play an online game, yep, you've run into this problem firsthand. It can also make video calls less efficient, forcing your data to go through a middleman server instead of going direct, which adds that really annoying lag. But here's the thing. NAT was only ever meant to be a temporary bandage. The real, permanent solution is a complete overhaul of the entire addressing system, and this ultimate upgrade is called IPv6. So instead of the 32-bit addresses from IPv4, this new system, IPv6, uses 128-bit addresses. Now, going from 32 to 128, it doesn't just double or quadruple the number of addresses. No, it expands the pool on a truly astronomical scale. And you can see the difference right here. The top address is a familiar-looking IPv4, just 4 blocks of numbers. The one on the bottom, though, that's an IPv6 address. It's way longer and it uses both numbers and letters. It might look a lot more complicated, but that complexity is the key to a virtually infinite supply of new addresses. To really wrap your head around the scale of this upgrade, let's try an analogy. Imagine that the entire pool of 4.3 billion IPv4 addresses could all fit into a single grain of sand. Well, if IPv4 is just one grain of sand, then the new IPv6 address space is large enough to give a unique IP address to every single grain of sand on planet Earth. The actual number is 340 undecillion. Let me put it simply. We will never, ever run out of addresses again. So let's quickly compare them side by side. For addresses, IPv4 is totally maxed out at 4.3 billion. IPv6, on the other hand, gives us a number so huge we can pretty much just call it infinite. But here's a really key insight. IPv6 isn't just bigger, it's smarter. The header, which you can think of as the routing info in a package of data, is actually simpler and more streamlined. This makes it way more efficient for modern routers to handle, which can lead to a faster, smoother internet for all of us. Okay, that's all the tech stuff. But what does this massive upgrade actually mean for you? Why should you even care about any of this for your day-to-day internet use? Well, the biggest change is this. With a nearly infinite number of addresses, we don't need that clumsy NAT workaround anymore. We can finally fire the receptionist. This means every single one of your devices can get its own unique public IP address, which restores the internet's original beautiful design for direct, seamless connections. And that translates into some very real benefits. For all you gamers out there, it means smoother online matches without those awful connection errors. For the rest of us, it means more direct paths for our video calls, which reduces lag and improves quality. And looking ahead, it provides the foundation for the Internet of Things. All those smart light bulbs, cars, and city sensors, they all need their own address, and IPv6 is what makes that possible. In fact, mobile networks already rely on it to handle millions of phones connecting at once. And there's one more huge benefit: security. With IPv4, security features were kind of bolted on as an afterthought, but with IPv6, security was baked right in from the very beginning. Key features that provide really strong encryption and authentication are a mandatory part of the new system, which makes the internet fundamentally more secure. So what's the big takeaway here? The best way to think about it is this. IPv4 was the architecture that was built for the dial-up era, and honestly, it's served us well. But IPv6, that's the modern fiber optic foundation. It is built for the scale, the speed, and the security that our future demands. The transition is happening slowly, behind the scenes, but it is the essential upgrade that will power our connected world for generations